Hello, here we are with the first question from the functions of several variables. The question says, a firm is the only producer of two goods X and Y. The demand quantities X and Y of X and Y respectively and the corresponding prices Px and Py are related by the equations Py minus Px plus 13 minus 6x equal to 0 and Px minus 4Py plus 26 minus 6y equal to 0. The firm's joint total cost function is 2x plus y. Find an expression in terms of x and y for the profit function. Determine the quantities x and y that maximize the firm's profit. Now, in this question, we are given demand equations which are related by the quantities x and y and their prices. Now, we will solve these two demand equations simultaneously to find prices in terms of x and y. Then we will be able to write the total revenue function. So, therefore, solution on the next page. Here we are, solution. The demand equations are Py minus Px, Py minus Px plus 13 minus 6x plus 13 minus 6x equal to 0. Name it as first equation. Then the second equation is Px minus 4Py, Px minus 4Py plus 26 minus 6y plus 26 minus 6y equal to 0. This is our second demand equation. Now we will solve these two demand equations simultaneously for the values of Px and Py. So, just adding these two equations will give us Py in terms of x and y. Now, writing these two equations again, minus Px plus Py plus 13 minus 6x equals 0. Then below it, Px minus 4Py plus 26 minus 6y equals 0. Draw the line, cancel Px. Then Py minus 4Py will give us minus 3Py plus 13 plus 26 will give us 39. Then minus 6x minus 6y equal 0. Now taking 3 common, Py minus 13 plus 2x plus 2y equal to 0. Cancel minus 3. This implies that Py minus 13 plus 2x plus 2y. This implies that Py equals 13 minus 2x minus 2y. Now we will put this Py in the first equation. So put in 1. Now first of all we will write the first equation, Py minus Px plus 13 minus 6x equals 0. Now we will replace this Py with the above value. So writing 13 minus 2x minus 2y for py, the remainder equation is minus px plus 13 minus 6x equal to 0. Simplifying the left side, 13 plus 13 makes 26, minus 2x minus 6x means minus 8x, and then minus 2y and minus px. We are searching for px, so px equals 26 minus 8x minus 2y. Now we are able to write the total revenue function. Total revenue function in terms of x and y equals xpx plus ypy. Now putting the values of px and py, we have x times px. Px is here 26 minus 8x minus 2y, then y py is here, look here, py equals 13 minus 2x minus 2y. Now simplify this a bit. 26x minus 8x square minus 2xy plus 13y minus 2xy minus 2y square. Now on the next page, here we are on the next page. Total revenue function equals 20 minus 8x square, then minus 2y square, then minus 2xy mean minus 4xy, then 26x, and finally 18y. Now the total cost function is 2x plus y. Therefore, the profit function in terms of x and y will be equal to total revenue in terms of x and y minus total cost in terms of x and y. Now replacing the values of total revenue and total cost functions, minus 8x square first, minus 2y square minus 4xy plus 26x plus 13y minus 2x plus y. This implies that minus 8x square minus 2y square minus 4xy plus 26x minus 2x will give you 24x. 13y minus y will give you 12y. Now this is the final profit function. Now we have to maximize it. Now we will find the partial derivatives. Finding the partial derivatives. Partial derivatives. Pi xx, pi xy, and pi xy. Therefore, partial derivative with respect to x is minus 8 times 2x minus 4y plus 24 minus 16x minus 4y plus 24. Now second derivative with respect to x will be minus 16 only, because these two terms are constant now. Now second order derivative with respect to y, we will partially differentiate this derivative with respect to x now with respect to y. So minus 16x is 0 because it is constant. Minus 4y will become minus 4. So this is the derivative xy. Now partial derivative with respect to y will be equal to minus 2 times 2y minus 4x plus 12. This implies that pi y equals minus 4y plus 12 minus 4x. Second order derivative with respect to y will be minus 4 now. Now to find the critical values, we will put the partial derivatives pi x and pi y equal to 0. For critical values, put pi x equal to 0 equal to pi y, that is pi x equal to 0 implies minus 16x minus 4y plus 24 equal to 0. This is our third equation. Similarly, pi y equal to 0 implies that minus 4y plus 12 minus 4x equal to 0. This is fourth equation. Now we will solve these equations simultaneous to find the values of x and y. Therefore, on the next page, now simply subtracting 3 and 4 will give us the value of x here. So minus 16x minus 4y plus 24 equal to 0. This is 3 minus 4. Equation 3 minus equation 4 implies then minus 4x minus 4y minus 4x minus 4y plus 12 equal to 0. Change the signs as we are subtracting. Minus 4y minus 4y cancelled, minus 16x plus 4x. So minus 12x is left. 24 minus 12, 12 equal to 0. From here 12x equals to 12. Dividing by 12, we will get x equal to 1. Now to find y, put in third equation. Put in 3. First side the third equation, minus 16x minus 4y plus 24 equal to 0. Now replace this x with 1. So minus 16 times 1 minus 4y plus 24 equal to 0. This implies that minus 16 minus 4y plus 24 equal to 0. This implies that 4y equals 24 minus 16 will give us 8. Dividing by 4, we will get y equals to 2. So the critical points are, the critical point is 1, 2. Now we will check whether this point is a point of maxima or a point of minima. Now we will use the Hessian. Hessian equals pi xx multiplied by pi yy minus pi xy whole square. Okay. Pi xx is minus 16. Pi yy is minus 4. Pi xy is minus 4 as well. Hessian equals 16 times 4 is 64 minus 16, which is equal to 64 minus 16, 48, which is positive, and also second order partial derivative with respect to x equals minus 16, which is negative. Now on the next page, therefore 1, 2 is a point of maxima, is a point of maxima. That is, this point will maximize the profit for the monopoly firm. Thank you very much for watching my video.